So we talked about the basics of Prolog last session. So we had a simple, popular example of the family relationships, and we saw how we can actually represent facts, rules, and so on using Prolog. Now, do you have any question about the first tutorial? Okay, so today I'm going to discuss a little bit more. For example, we start with list, how we can actually define list, check for like a member of a list in Prolog, and if time permits, we also do like unification and recursion. So this week, basically, I'm going to spend the whole week on just Prolog. We'll also have some, probably next session, we'll do some more fun examples, like, for example, the queen attack. If you wanted to check, you can have a quick look at the queen attack or other puzzles, like the zebra puzzles and similar puzzles in Prolog. They're quite fun because they are like the games, and so you will have more fun compared to other sessions. So that would be, I think, Thursday. So for today, we so first, how many of you have installed Prolog? How many of you have tried to install Prolog but failed? Like, how many of you tried but failed? Okay, and the rest didn't even try. Thank you. Yeah, I'm actually using it with Visual Studio. Yeah, so you can use VS Code if you want.
In your installation guides,
Mm-hmm.
you have to map Windows if you use Linux for. Is that fine?
I'm sorry?
You only have to map Windows, or will you have to use Linux as well?
In the link that I sent you for the Prolog tutorial file, there
guidance on Linux. Also on that Windows machine has
so it doesn't have the instruction for the Linux.
they do on their website. I just want to make sure that's fine for anyone who uses it.
Yeah, sure.
Okay.
Yeah, it's fine. And so, okay, I feel my ear. Recently, I feel I cannot hear really well, so got a bit old, I guess. And so please talk a bit louder when you're talking to me. And so list, you probably have had the Python course or like Introduction to Computer Science course. So you are, I assume that you are more or less familiar with the list. So lists are just to store collection of elements. Now this element can be a constant, could be a variable. Now we have also other like more fancy types of things in Prolog, like atoms and terms. So list could also include terms, atoms, and so on. It could include like complex terms as well. So it could include anything. Now, the first one that you see here is just an empty list. And also you always show a list with inside a bracket, okay? So if, for example, whatever element that your list has, like if there are just numbers 1, 2, 3, 4, you include them inside a bracket, and then that will be called a list. So this one, the first one, represents a list with no elements. And the way Prolog treats empty list is interesting, and we'll see later why. I'm not going to put any comment on that right now. And so non-empty list could include anything. Like here, for example, we have ABC. Like these are the 3 elements. What is the length of this list? 3, right? What is the length of the first one? An empty list? 0, right? And then it could also have like any type of data types here. Like, for example, we have Mona, which is just simply an atom here, a teacher, John, a more complex term, right, with a functor here, and John. So One thing I wanted to also explain about functors, so you probably have seen it if you have checked the tutorials, but you may not know what is this difference with the function. So just wanted to clear things out. So in FOL, like in first order logic, we have functions, right? So for instance, we said that functions are used to map objects to other objects, right? And so for example, if I write father John, right? So there might be lots of confusion here in terms of, okay, why is it a predicate, why is it a function, when is it a functor, and so on. So just a distinction between a function and a functor for now. So in Prolog, we don't have, so for example, let's say father of John is, I don't know, Alex. Or for example, you say grade of Mona on test 1, okay, is, I don't know, 90%. So we don't have such things in Prolog. So in Prolog, we don't have, like, for example, if you have grade Mona test 1, so you have to give it like this. And then, for example. Now, depending on the context of where you're using it, you call it a functor or function. So for example, in Prolog, we call it a functor, and you don't have to, it is not actually the way, in a similar way that you were defining function in FOL, right? And so for instance, if you just write grade Mona test 1, so it doesn't have any meaning, right? We have to explain Prolog explicitly what is, for example, Mona's grade in test 1. You either have to provide some facts for it to understand, or you're gonna define it as like a rules, right? And in terms of predicates, as I mentioned before, they are just statements that can return true or false. So for instance, whenever you are using it in a query, like if you're writing a query, which can return, for example, yes, no, true, false, then it is a predicate. So the same sentence may be a predicate or, for example, function or functor, depending on where we are going to use it. So later we'll see more examples, and like gradually you'll be more familiar with it. But I wanted just to provide the distinction here. And then we can also have a list inside a list. So it's a nested list. We can also have a list inside a list inside a list, and go so on. So just a few notes here. I already mentioned that you have to define your list inside a bracket, and that you are separating the elements of a list by comma, right? A, B, C, and so on. And so let's take a look at this list. What is the length of this list? Length of a list is the number of elements in this list, right? How many elements do we have in this list? 3 elements, right? This is the first element, the second element, which is a list itself, and then the third element. And also, element can happen more than once in the same list. So for instance, you can have a list that Mona appears 2 times, or your variables appear 2 times or more. Now, you want to check, for example, if a specific like term, variable, or any other data type that you want to check if it is a member of your list. So that's very simple. You can use member arity tool, right, which takes, for example, the variable that you're looking for, and then followed by the list. So for instance, this check whether X is in ABC, which should return false, right? So for instance, if I'm having ignore just this part. This is for the previous example. So we are just working here. Now, let's say, for example, I want to check, and you know how to access, how you have to actually start writing your code in Prolog, right? Right now, I'm in the correct path, the correct directory. But if not, if, for instance, let me close here. Okay. So I'm gonna open a new terminal. So you always type triple, and then you have to check where you are. Okay. So you check, for example, I'm in users Mona, but my code, like all the Prolog codes, I stored in another folder. So you just go to that folder like this, and don't forget the full stop at the end. And then you just want to check, for example, if X is a member of this list, right? Oh, sorry. This is here. And so it checks one by one. So I'm going to explain it later how it works. So for instance, if you're using, for example, member X, A, B, C, it checks in this list, right? So the way that it works, check if an element, for example, X in this example is here. So the first one that it checks is with the A, and then with the B, and then with the C, and then, for example, return false, okay? Now, this example was not a good one because I was actually using here, let me, then I will explain the other example later. So who can tell me why it's going to be like this and not here? I explained it in previous session. Semicolon, right? So you can get the next result by semicolon, but if you just want to like stop, then you put the full stop, okay? Now, so you can continue with the semicolon, go there. Now, this was just a simple example, but like theoretically, we want to see how actually Prolog finds an answer. So this is the important part that you have to know. So the first line, member X, which is the head here, and T is the tail. And so here, head, for now, you can just think of the head as the first element in a list, and the rest of the list is the tail, okay? So for example, if you have A, B, C, okay? And if you write, for example, head, tail is equal to this, then Prolog should return head is equal to A, right? And then tail is B and C. So first element always head, whatever we have after that is the tail. And these are not something special, so it's like you can write head and tail, right? You can write X and Y. So whatever you write, so the important thing is this operator, right? So whatever comes before this operator is your head, which is the first element. Whatever comes after this is your tail. And so here it says, like the first clause says, X is a member of a list, okay, if it is the head of that list. Okay, so this is the easiest way and the simplest case, and this is the way that the first way that always Prolog checks. So whatever you want to like search in your list, it always checks first with the head, which is this case, and then if this X is the first element, then it's true, right? Because it exists in the list. Now, what if it's not in the first, like the variable, for example, you are searching for is not the first element, or it's not the head. So you're, for example, searching for C, okay, somewhere like after that. So it first check this one. So it check first member X and X is head or not. So if it is not, so if this is a head which doesn't contain X, so for example, you can see this example. It checks, for example, Mona in this list. Mona, Robert, Antonella, okay? So in this case, first check this one, right? And this is true, so it doesn't do anything further. Now, what if it want to check this query? So you want to check if Mona exists here. So basically, whatever, like both of these, if you write these two queries in Prolog, both returns true because Mona exists in the list, right? The thing that I want to explain here is the difference between how Prolog search in like these two cases. So in the first case, it starts with member X, and X is the head, so it stops and returns true. But in the second case, the reason I wrote here that the rule is recursive, and this is very important, and I'm going to further discuss recursion either today or next session, is that it first checks Mona with the head, which is Robert, right? So does it succeed? No, it fails. So it goes to the rest of the list. So now the remaining of the list is Alan, Mona, Julia, right? Now the next time it checks whether Mona is member of this list. So what you see here, like member so this is when your head is X, and either you have member some head, right, and T, and this is if X is a member of T. And this is a list, I guess. No. Okay, so in the example, for example, the second example is checking member Mona, and then what was that? I don't want Mona the first, like Robert Allen Mona. Check whether Mona is in this list. So, for example, maybe something else. Now, so in this case, it checked first this one. So this is your head, right? This is the head, and this is your X. So is X equal to head? No. So it goes to this recursive one. So here it checks whether your X, which is Mona, exists in the tail part. So for example, in L and Mona, right? Now to check whether Mona exists in L and Mona, it again has to check the first, the head, right? Because it's recursive. So now it checks whether Mona is a member of, for example, Ellen, Mona, this list. Okay, right? And this is your X here, this is your head. Does it succeed? No. So it recursively check with the rest of the list, which is the tail, here, right? So we check if X is in the T. Now this time check if Mona is here. So it matched the head. So you could also have more in the example I provided you had, but in this case you don't have. Now what about this one? So it succeeds. So this is actually how Prolog search for a member in a list. Yes.
From the member X, square brackets X/T in Prolog, I get true, which makes sense. And then if I hit semicolon, it starts returning to me like T is equal to the square bracket, like increasing this. Is that supposed to happen? Like,
can I see?
Oh, sure. So if I do this.
Yeah, because it's not clear what size is X and T, so recursively. So I'm going to explain this anonymous. This is an anonymous variable. So I'm also going to explain that today. So when you want to, like, for example, let's say search for third and fifth element of a list, but you don't care about the rest. Like your list has like 20 members, you want to like just return those two and forget about the rest. So so this was the example. So it, here it finds a match, and then the query succeeds, and then you're fine, right? Now, what if the query, we write a query that fails? Like what if, for example, in our original list here, we had, for example, where was the original list? So let's say here you had, I don't know, Alex, Robert, Antonella, and you were looking for Mona. So how does it work? Let's say this. Okay, so it starts with this one. Check if Mona is equal to the head, which is not, right? So it goes to the tail, which is a list, Ellen and Alex. Check with the head again, which is Ellen, right? Again, it doesn't match, right? So it goes to the next, like the remaining, which is the tail here, is only Alex. It checked with Alex and it fails. So it should return false, which returns and is true. But how does Prolog actually process that? Sorry? It's actually based on the concept of the empty list that, so for example here, sorry? Okay, I thought someone want to answer. So you remember that we said that empty list is special in Prolog, so it considered as a special type of list. So for example, if for an empty list you want to get head or tail, what happens? So get the head of an empty list. So what if your empty list, I ask what is the head or what is the tail? Prolog doesn't, that's why I said that it treats an empty list as a special type of list. So the definition here that we have is actually for the head and tail is for any non-empty list, okay? So it doesn't have any head or tail. So because it doesn't have head and tail, when it reaches to like the end here, which is like an empty list, it doesn't have anything to check any further because we don't have head and tail, right? So it correctly stops, which should stop. So here is the explanation if you want. The recursive rule relies on splitting the list into head and tail, right? This is what we have done here. And then list cannot be split in this way, the empty list, right? So the recursive rule which we wrote here cannot be applied and Prolog stops. So let's talk more about the head and tail. So it is, we just want to like practice a little bit more. So as I mentioned, head is just the first element, and then tail is a list of the remaining elements. Yes?
Sorry, is there a way to check one by one, or like, does it always just check instantaneously? Because like, I know we can go over all the variables if we, I'll go over all the members of the list if we just put a variable in. But like, if we're just doing a generic just, can we like go do the check one by one?
You mean if we are looking for, like if we have a large list, long list, and we are looking for specific items in that list, and we don't want to like get them one by one, return, we don't want Prolog to return like one by one, all of them?
No, never mind, I can just ask you. I'll just ask you later.
Okay, so so here's one example, simple example. So here is the head and the tail is the list. So I want you to note this, the way that Prolog returns the head as an element and the tail as a list, okay? So return the first one as one, which is just an element, and then the remaining part as a list. Now let's say we have this list which includes like everything, right? It has an empty list, it has a complex term, it has a like nested list, and so on. So again, if you get the head, it returns the first element, which is an empty list, and then the tail is the rest. And as I mentioned, if you want to get the head and tail of an empty list, it will return false because it's a special type of list and it doesn't have head and tail. And now this is another like easy example. Just return the first element. Now this is just what I mentioned. So it is nothing special about ht. So you can replace it with any variable that you want, x, y, or anything. So now what if we want to see what are the first, for example, 2 elements of a list, right? So we don't want to like search for a specific member like Mona in a list, but we want to see what are the first 2 elements. So still you can use this operator. So this operator not only return the head and tail, but also you can use it to split the list at any point that you want, okay? So you want to, like, for example, get the first 2 1, you get 2 variables x, y for the x for the first one, y for the second one, and then the rest is just the tail. So whatever comes after this operator. So the first 2 elements, if you write this, x, y, and w, then you have this list, you get Mona, Paolo, and this. Okay, clear, right? Now, you want to like write this. So, for instance, here, okay. So it should return the first one, which is an empty list. This should be your x, and this should be your y, right? And then w should be a list containing all these final elements. So, which actually did, right? Now, what if you want to like get, for example, in this list, you want to get, for example, the second element and 4th element. Or, for example, you want to get the first one and the 3rd one. How can you do that? So for the first 2, we wrote like x for this one, y for this one, right? For the first 3, maybe we can add another variable, but we may have a large list and we want to get like some specific elements. So in that case, you can use anonymous variable. So whenever you see this underline in Prolog, so for instance, if you see something like this, okay, so we call this like underline as an anonymous variable. That is because, for instance, if you want to get the first and third element of a list, so basically you can just write x1, x2, x3, or xyz, right? And then the rest is a wt or whatever. And then you have like this list, right? So for instance, if you just write this, so let me even actually change these names so we can have like x, y, z the same. And then we can have t here, which is your tail. And then you can have like a very large list. Let's use the same list that we have here, the same example. Now, it should return like the first one, right, which is the empty list. And then, so I'm zooming in. The second one, also the second one, which is teacher Mona, the third one. So it returned actually what we want, the first and third element. What's the problem with this method?
Also gives the second one.
Yeah, it returns everything, including what we are interested in, but we may not be interested in the rest of that. Maybe it's like a larger list. We don't want to like see everything here. So if you want to like specifically get, let's say, the first one and the third one here, so you can replace like this XYZ, right? Like wherever you are not interested in, you can put underline, and the ones that you are interested in, you can put your variable like X, Y, or whatever. So now if I write, for instance, this Y and so you can actually play with it, like with different things. And then let's use the same list. So it returns the first one. So it ignores actually the first. And then Y is the second one, which is teacher Mona here. And then the Z is this one, right? And then we have the tail, because the tail is actually whatever we have after that. So if you didn't have this here, then it would have returned only Y, which is teacher Mona, and then the rest would have been the tail, okay? Now, in this case, for instance, this one, we see that it returned everything. And we said, okay, now we want to like see only the first one and the third one. So you can put underline here. Sorry, x1 here, then underline, and then, yeah.
So Professor, in this the second element, is it written as a function or that's just an element for it?
Which?
Teacher Mona. So is that a function for it or is it written just as an element?
Function or functor?
Function.
No, it is not a function. That is why I was explaining it at the beginning. So whenever you see like it as a term that is applied inside another structure, that is, for example, within a list, right? So it is, for here, it is not mapping any object to any object, right? So in this case, it is just a functor, okay? So whenever you see it, for example, inside another structure, like for example a list, or could be any other structure, and if you see it in a query that want to return, for example, true false, then it is a predicate. And that is if for example we have, for example, let's say we have some facts, we know who is the father of, who is, for example, whether Mona is a teacher or not, and then in that case could also serve as a predicate. So
it's in a list?
No, if it is, as I mentioned, if it is inside another structure, like for example in a list, because here, does it map any object to any object? No, it's just like a data, right? You can think of it as kind of a data stored somewhere. So in this case, it's just a functor. We call it a functor. If you wanted to serve or simulate a function, a function that we had in FOL that is mapping objects to objects, then you have to explicitly define either facts or rules by which you can infer, for example, what is, for example, not for example this sentence. For example, if you have father of someone, then you can map it to another. For teacher Mona, it could be like, for example, teacher of Mona. Yeah, in that case also you could also use it as a function, but not inside the list. Now, so okay, as I mentioned, if you want to get the first and the third, then you can just simply have like this, right? This is whatever x, whatever y, right? Sorry, this example used the fourth, second and fourth, right? So whatever you are interested in, you put your variables, but the rest that you're not interested in are anonymous variables. And anonymous because we are not interested in them. So if it is like first and third, in that case, you would have x1, then underline, and then y. If you want like get the second, for example, and the fifth element, then you are gonna like put only variables for the second and fifth element, and the rest would be anonymous or underlined. Similarly here, if you want to get the second and fourth element, you can just write anonymous because you're not interested in the first. You put variable for the second one and the fourth one, and the rest always the anonymous variable, right? So this one should return the second, which is teacher Mona, right? And the fourth one, which is an empty list. And the rest is just, we are not interested. That is why, like for the tail, we just wrote anything. So if you put T here or Z here, what would happen? It would also return the tail of the list, right? So after, for example, here X and Y, it will also return the tail. Now, let's see a little bit more complex example. Let's try, I know it's hard because I already provided the solutions here, but please try to think first and then write it yourself and check what was the problem. So for example, if you want to get an element of an internal list, so for instance here, we have this bigger list, right? This is our bigger list, which includes some other list. For example, the third element is a list, right? Now, what if we want to get an element of this internal list? How can you use anonymous variable so that you can get this? Do you want to try? I don't see anyone typing anything. Yeah.
Like the previous example, probably just, so you have like an uppercase, like a variable, like x, comma, then underscore to get rid of the tail. If you just want one.
Yeah, but when you reach the list, you have to write the list operator again. So again, we are not interested in the first and second, right? We are interested in the third element, right? But not the whole third element. So when you reach to the third element, which is a list, now you are interested in, for example, the first element, which is A, for example. Or you are interested in the head of this example. So you want to get a head of this list. Who could do that? Yeah.
We can use anonymous variable for the ones that we are not interested in, and just put variable for the first element inside in the nested list.
So for instance, in this case, am I going to write, for instance, underline, and then underline again for the second element?
We have the rest, like the list of A, 1, 2, but we only put like variable for the A and put underline for the rest.
Yeah.
So the way that I did it, so you do like both the same thing over there, underscore, comma, you do an open bracket,
Mm-hmm.
do X, comma, underscore, close bracket, and then the rest.
Yeah, yeah, that's true. So as your friends mentioned, you just put like whatever you're not interested, put underline. So you have like this, again, bracket, underline for the first element, underline for the second element. Now you reach to the third element, which is a list, right? So you write a list in this way, and then which part of the list are you interested in? So your list is A, 1, and 2, right? This is your third element. This was the third element in our bigger list. Now, if we are interested, let's say, on the head of this one, so when we are, okay, we said in the bigger list, we said, okay, we are not interested in the first element, so we put underline. We are not interested in the second element, so another underline here, right? Now, the third element here, we want to go deeper inside, so we want the head, right? You can write H, X, or whatever. And then we are not, again, interested in the rest. Sorry. We are not interested in the tail. And then you continue for the other elements. So as you see here, so we have, so this example is for the tail. I wrote it for the head, but it doesn't matter. So for example, if we want to just get the tail of this one, right? The tail of the third element is this, then you just write underline for the first, underline for the second, and then your third element, which is a list, you have underline tail, right? Because you're interested in the tail, and then you're not interested in the rest. So you want to see how it works. So it gets the tail, but the tail itself is a list, right? So it always returns the tail as a list, even if it was just 1 and 2, okay? So it always returns as a list. Now, getting the first element of the list inside our internal list, so instead of getting this part, we want to get the first one. So again, you're not interested in the first element, you're not interested in the second element, so you put underline for those. We reach to the third element. Now, okay, this is even going one step more into the list, right? Because we have, here we have 3 like nested lists, right? So we have like this bigger list here. So one element, the third element was a list, right, and something else. Now this third element was also a list, right? But it also has another list inside. So this is the third list inside the second list, inside the first list. So the next question is, what if so far we know how we reach the whole third element, right? So you want to put like this, and then the third element, whatever variable you want to write, and then the rest. Or, for example, if you want to like have this, you reach the tail. Or we want to like get, for instance, the head or the tail of this third element, which when we reach here, we write the list, right? And then, for instance, we are not interested in the first part, we only want to get the tail part, so you write the tail, or whatever. Now, what if we want to like reach, let's say, 1 or 2, like the first element or the second element here? So again, we go up to here, right? We already have this part. But now, we have to further break this one too, right? So now, we are, for example, interested within that list. For example, we are interested, let's say, in the head or tail or whichever, first, second, third, like this only has 2 variables, but it could have 2 elements. It could have even like 5. You are checking, for example, for the 4th element. So you only you continue the same way. So you reach to the third element, which is this one, right? Now you go inside this third one. You are not interested in A, right? You are not interested in the first element, so you put underline here. Now, inside this list, so this is your third inner list. Inside this list, you're looking for the head, or whatever that you look for, you just write it. So it should return head 1. If you are looking for the tail, it will return 2. Now, why did it return if you write it this way? Now, here's a question. So this one returned head 1, right? Now, if I'm interested in the tail, I put underline here and then X or maybe tail, just for clarity, here. So why did it return the first one as an element, the second one as a list? Yeah, it always returned tail as the list. Yeah.
I'm a little confused. Why isn't there like a bracket in the inner? Like if you
No bracket where?
not a bracket, sorry. What do you call this symbol?
Yeah, I don't know.
Yeah,
This
vertical one. Like after like the I don't know how to tell. After like head and then vertical line.
Here, are you talking about this part?
Yeah.
Okay.
That part.
So
Like,
after this symbol,
no, not just no before.
here, after this symbol,
2 characters, like 2 characters to the right.
here,
Yeah, after that symbol.
yeah.
Why isn't there like a straight vertical line? Because like all the other lists, they end with a straight vertical line as well.
Because we are within a third inner list, not the second inner list. Okay? So I was explaining here, this was our biggest list, right? So these 2 brackets are for that one, right? And then we have another list, which is this one. This is A1, 2, right? So you should have this part, right? Now for the example that you are asking, now we have this. Now this also breaks more, right? Into another list, which is this one. So you also have to have this bracket, right? So the reason you see here, like this bracket and not instantly the symbol here is because you have to first close your bracket, which was for the second list, right?
Shouldn't there be like a vertical line after that bracket, like within those 2?
No, because it would mean that it would return the tail of the second list. Okay?
Alright, just like whenever
We already I'm sorry?
it just like like you could always put a underline after the tail, but like if you try doing that for the outer layers, like just not adding a tail portion, then it doesn't work. So I'm confused on why it works for the bottom, for like the inner portion, like the very most inner portion. There's no like tail portion.
If you don't write which part, sorry, it doesn't work. So you can try, like if, for instance, if you think that you have to, for example, put this symbol earlier, just try it and see what's the output. That's the best way you can actually learn. So now this one for you. How about the second or the last element of the list inside our internal list? So now we want to get this one, right? Which is inside this list, which itself is inside this list, right? Which itself is inside the bigger list. How do you reach that? It's almost the same as the first one that we got, the head, right? So now we want to get the second element, or like the last element. So the same, you see? Again, we are not interested in the first, which is this one. We are not interested in the second, which is here. Then we reach to a list, right? This is our list, right? And so we are looking for elements like inside our third element. So that is why you have like this here, this symbol here, and then underline, because you're not interested in anything that happens after, okay? So you can write this first. You can write this way, underline, underline, and then you have the third element, right? And then, are you interested in the rest? No, the rest is the tail. You're not interested. So you have this, right? Now, I suggest you always do it like this. Go from the outer list into the inner one. So now inside the third element, then you see which part you're interested in and which part you're not. For the parts that you're not interested in, you just put underline, right? Let's say we are interested in the second part, which is also a list, right? Then you put underline here, and then continue. Now, if you want to even go deeper into that list, you again have to somehow show that list, right? And then you just put head, tail, or whatever variable that you want, and anonymous variables, like the way that you have here. Yes?
If our list only has one element, and then we write like underscore and then tail, so give us an empty list.
So let's say we have an empty, you have a list with one variable, okay?
And then, so we write like underline and then tail.
Mm-hmm.
So does it give us an empty list?
We can test. So we have a list. So you write underline, right?
Yeah.
And then tail, like that. So the first should be head. And then what is your list?
A list of one element.
Like this?
Yeah.
Yeah. And so this one should give us this variable, right? Because we have underline for the first, underline for the second. Now, when you reach to the third element, which is where we are interested, put that bracket there first. And then also put that symbol and underline so that you're done with the whole structure, right? And then you go deeper into your list. Now, for example, in the third element, we are interested, if you are interested, let's say in A, or for example, in the tail, which is 1 and 2, then you only have one other list there. But if you are interested in, let's say, 1, accessing this first element within this, the most inner list here, then as you see here, you have to open another bracket, right? This is showing our third inner list. So this is the third inner list here. It means that now we have accessed this list, which includes 1 and 2 as its element. Now, let's say we have a list that is 1 and 2. And what we wrote here is basically saying underline, right? And then y, or x. And always put like this as uppercase so that Prolog knows that it is a variable. So what should this one return? Yeah, so we are not interested in the first, but we are interested in the tail, and the tail here is 2. So as you see, it returned 2, and it returned it as a list because it is a tail. So it always returns tail as a list. Yeah.
So if we, instead of vertical line, if we do underscore
then it will give 2, right?
Here,
Yeah, if instead of the vertical line we use comma, like underscore comma y,
so let me write.
then underscore
Mhm.
comma and then y. That will be taken. Yeah, then we get 2, right? Not
I think so, because then it doesn't know, because that symbol help Prolog knows that you want to get like head or tail, right? But otherwise, I don't think it gets. Like, we can check. So let's say, for instance, if we have, in the first case, we have underline y, right? And the list is, let's say, 1, 2, right? So this one returns y2, exactly. Yeah. If you put it this way, then it knows that it is a tail, right?
If after the underscore and y, we have one cross and then another underline, we still get 2.
After the underscore here,
No, so for the question that we asked,
Mhm.
for the second that
This
we
one?
asked, yeah, if you have another cross and then another underline, we still get 2, right? But
So what should I, like, we have under?
so one cross so after the y, we have one line, one cross line, and then also, yeah, one vertical line, and then one under, and then one underline.
Like this?
Yeah, still get 2.
And then what is your list?
The same list, like 1 and 2.
Yeah, okay. So we have underline and y,
Yeah.
and then underline again. So it should, okay, so this means that you're not interested in the first element, you are interested in the second element, and you don't care about the rest. So the second element here is 2, so it should return 2, right? But it's not the tail here, right? So it shouldn't return it as a list, I guess. So we can just check. Yeah, it just returned it as like an element. Yeah. And so just give me a second